Hello students, today I will solve some important questions on function of several variables including partial derivatives, and this is the most important question of partial derivatives. Here three parts are there and u is a function of xyz log of x cube plus y cube plus z cube minus 3xyz. Then we have to solve these three parts. First part is easy, but most of the students facing problem to solve the second and third part, mostly the second part. So let us start the solution. Let u equal to log of x cube plus y cube plus z cube minus 3xyz. This is the given function. So you know that we can expand this as the formula is x plus y plus z into x square plus y square plus z square minus xy minus yz minus zx. Then by using logarithmic formula, log of ab equal to log a plus log b, so we can write log of x plus y plus z plus log of x square plus y square plus z square minus xy minus yz minus zx, which is equal to log of p plus log of q, where p is x plus y plus z and q is x square plus y square plus z square minus xy minus yz minus zx. Now we have to find out del u del x, del u del y and del u del z, because the first part is summation of these three. So when you derive with respect to x, then u equal to log of x cube plus y cube plus z cube minus 3xyz gives us ux equal to 3x square minus 3yz by x cube plus y cube plus z cube minus 3xyz. Uy equal to similarly 3y square minus 3xz by the same thing, and uz will be 3z square minus 3xy by x cube plus y cube plus z cube minus 3xyz, because u is a symmetric function on xyz. Now if you sum ux plus uy plus uz, then the denominator will be same, x cube plus y cube plus z cube minus 3xyz, and numerator will be summation of the above things. That is, if we take 3 outside, then 3 into x square plus y square plus z square minus xy minus yz minus zx, that is 3q. So we can write this as 3, we can write this as 3q, because q is the quantity and denominator is pq, because p is x plus y plus z and q is this. So we can write this as pq. Then q and q will be cancelled out. So this is 3 by p equal to 3 by x plus y plus z. And this is what we have to prove, because p equal to x plus y plus z. So first part is done, and this is very easy part. Now for the second part, we already have the first part, del del x plus del del y plus del del z, u equal to 3 by x plus y plus z. By the first part we can write this. If we again apply this operator over u, then the left hand side will be del del x plus del del y plus del del z over power 2 over u equal to, in the right hand side again we will apply the operator. So del del x plus del del y plus del del z will be applied on 3 by x plus y plus z. So if we do 1 by 1 del del x and del del y and del del z, then we will sum those. So first calculate del del x of 3 by x plus y plus z. That is, you know, this will be, if we derive with respect to x, then the denominator will be x plus y plus z whole square, and the numerator will be 3 into 1, and 1 minus will be there. Similarly, del del y of 3 by x plus y plus z will be equal to minus 3 by x plus y plus z whole square, or you can write minus 3 by p square, because p is equal to x plus y plus z. And similarly for del del z, 3 by x plus y plus z will be equal to minus 3 by again p square or x plus y plus z square. So if we add all these, then in the right hand side we will be getting minus 3 into 3 by x plus y plus z whole square. So this is minus 9 by x plus y plus z whole square. So in the question, part 3 is done. Now only we have to prove part 2. This is the main important part. So we have del x plus del y plus del z to u equal to minus 9 by x plus y plus z whole square. This we can get from the part 3. So if you break this, then the formula is uxx plus uyy plus uzz plus 2 into uxy plus uyz plus uzx, or you can write as del 2u del x2 del 2u del y2 del 2u del z2 in this way. And the right hand side is minus 9 by x plus y plus z whole square. But we need only this part, that is uxx plus uyy plus uzz. We need only this part. So if we can calculate the second part, that is uxy plus uyz plus uzx, then from this equation we can get the value of this first part, and we only need the first part. So let us solve this uxy, uyz and uzx. Since the function is symmetric, we will do only uxy. Now u equal to log p plus log q, where p equal to x plus y plus z and q equal to x square plus y square plus z square minus xy minus yz minus zx. Then we need uxy. So to find uxy, first we will calculate ux, and ux will be 1 by p plus 1 by q. Ux will be 1 by p and then derivative of p with respect to x, and for the second part it will be 1 by q and derivative of q with respect to x. So 2x minus y minus z. So this is our ux. Now we need uxy, that is we have to derive ux with respect to y. So if we derive ux with respect to y, from 1 by p we will get minus 1 by p square, and derivative of p with respect to y is 1, plus derivative of this we will use f by g formula. So denominator will be q square and numerator will be q into derivative of 2x minus y minus z with respect to y, which is minus 1, minus 2x minus y minus z into derivative of q with respect to y, that will be 2y minus x minus z. So finally minus 1 by p square minus 1 by q and then minus 2x minus y minus z into 2y minus x minus z by q square. And then the denominator is q square. So we need to simplify the above part, 2x minus y minus z and 2y minus x minus z. If we simplify this, this will be 4xy minus 2y square minus 2yz minus 2x square plus xy plus xz minus 2xz plus yz plus z square. Again we can write this as 4xy minus 2y square minus 2x square minus minus yz minus xz, and since we have one more xy, so it will be 5xy, and then plus z square. So uxy is now minus 1 by p square minus 1 by q minus 5xy minus 2y square minus 2x square minus yz minus xz plus z square by q. Now since the function is symmetric, we can write uyz and uzx by only seeing this uxy. So uyz will be similarly minus 1 by p square minus 1 by q minus the numerator will be 5yz minus 2y square minus 2z square minus x square minus xy minus zx and the denominator will be q square. Similarly, u zx will be minus 1 by p square minus 1 by q minus the denominator is q square and the numerator is 5zx minus 2z square minus 2x square plus y square minus xy minus zy. So we need the summation of uxy plus uyz plus uzx. So if we add all these, then the summation will be minus 3 by p square minus 3 by q, and then minus, if we add all these terms, then we can get 3 common, and then x square plus y square plus z square minus xy minus yz minus zx by q square, and then minus 3 by p square minus 3 by q. This will be minus actually will be outside. So minus 3 we have to take common, then plus 3 by q. So the final is minus 3 by p square. So we need this first term, that is we need uxx plus uyy plus uzz. This value we need, plus we can write the value of uxy plus uyz plus uzx, which is minus 3 by p square. We obtain this equal to minus 9 by p square, because p equal to x plus y plus z. And then the value is minus 9 by p square plus 6 by p square, which is equal to minus 3 by p square. That is minus 3 by x plus y plus z whole square. So we have proved the second part. Next, move on to the second question. So this is very easy question of chain rule. The function z equal to sin uv, which is a function of u and v, where u equal to 3x square and v equal to log x. So to find dz dx, we have to write the formula using chain rule. We can write del z del x, del z del u and du dx. Why? Because z is a function of u and v, so you will use partial derivative, and u is a function of single variable x, v is also a function of single variable. That's why we have written del z del u and du dx plus del z del v dv dx, because z is a function of u and v. So by chain rule we have to take both, and del z del u will be v cos uv, du dx is 6x plus del z del v is cos uv with one u outside, and then dv dx is 1 by x. So write properly, 6x v cos uv plus u by x cos uv. This is very easy question. So next move on to the third question. This is a question of again partial derivative. So f is a function where v is a function of xyz. Then we have to show 1 by x del v del x plus 1 by y del v del y plus 1 by z del v del z equal to 1 by v. So since f is a function of v square minus x square and so on, let us take a equal to v square minus x square, b equal to v square minus y square, and c equal to v square minus z square. Always you have to solve this type of question in this way. You have to take a, b, c. So now f is a function of a, b and c. So if we derivative with respect to x, then del f del x will be equal to 0, because the right hand side is 0. Now we will use chain rule. Del f del x is actually del f del a del x plus del f del b del x plus del f del c del x. Why? Because f is a function of a, b, c, and a, b, c are function of x, y, z, and the right hand side is 0. Now del f del a, and what is the value of del a del x? A equal to v square minus x square. So it will be 2v del x minus 2x. Why? Because v is a function of x, y, z. Similarly, del f del b into del b del x. So it will be 2v del x. plus del f del c into 2v del v del x, because v is a function of x, y, z, equal to 0. Now take common 2v del v del x, then we will be getting del f del a or fa plus fb plus fc, which is equal to 2x fa. Now write 2v and vx in place of del v del x, then it is 2x fa by fa plus fb plus fc, and then 2 and 2 will be cancelled out. So take v by x, vx, this is equal to fa by fa plus fb plus fc, because we have in the expression v by x type or 1 by x del v del x. So we have taken 1 by x vx into v equal to this. And similarly, since the function f is a symmetric function, so we can write v by y, vy equal to fb by fa plus fb plus fc, and similarly v by z, vz equal to fc by fa plus fb plus fc. We do not need to do all the cases, only one case is enough. So if we add all these, then v by x, vx plus v by y, vy plus v by z, vz equal to, the right hand side LCM is fa plus fb plus fc, and the numerator will be fa plus fb plus fc. So cancel out, it will be 1. Now we have in our expression 1 by x del v del x plus 1 by y del v del y plus 1 by z del v del z. So write those, 1 by y del v del y plus 1 by z del v del z, and take v in the right hand side. So it will be 1 by v. Hence we are done. The expression is proved now. Next question. If f is a function of f of x, y, z, w equal to 0, then we have to prove this multiplication equal to 1. Look, we have to find del x del y. That means we have to take x as a function of y and consider z and w constant. For the first time, consider z and w constant and x is a function of y. Now we have to find del x del y. So calculate f or differentiate f with respect to y. Then del f del y plus, if we differentiate with respect to y, then it will be del f del x and del x del y, because x is a function of y in this case and zw is constant. So it will be fy plus fx into del x del y equal to 0, and then del x del y will be equal to minus fy by fx. And similarly, we can find del y del z del w and del w del x. How? So when we calculate del y del z, then we have to take y as a function of z and x and w are constant. And similarly, del z del w will be in the same way equal to minus fw by minus fz. And similarly, we can write del w del x equal to minus fx by fw. So we need the multiplication of all these, that is del x del y into del y del z into del z del w into del w del x, which will be equal to, substituting the values, fy minus fy fx into minus fz fy into minus fw fz into minus fx fw, and then we can cancel out all the things, because fx, fw, fz, fy all will be cancelled out. Hence the final result is 1. Next question. Again the same question like the previous one. u equal to f of y minus z, z minus x minus y. So consider y minus z as a, z minus x as b, and x minus y as c. And then u is a function of, or f is a function of a, b, c. Now calculate del u del x. So by chain rule, it will be del u del a and del a del x plus del u del b del x plus del u del c del x. Then del u del a and del a del x is 0 because a equal to y minus z. Second one, del u del b and del b del x is minus 1. And del u del c del x is plus 1. So it will be minus del u del b plus del u del c. Similarly, by seeing this one, you can find del u del y and del u del z. See, if we calculate del u del y, then we need del a del y, del b del y, del c del y. But y is in positive term for a and y is in negative term for c, and no y term in b. So it will be del u del a minus del u del c. And similarly, for del u del z, you can see in a z is in minus term and in b z is in plus term. So this will be del u del a minus minus del u del a plus del u del b. Hence, if you add all these to find ux plus uy plus uz, then you can see del u del a minus del u del a will be cancelled out, del u del c minus del u del c, and del u del b minus del u del b will be cancelled out. So the final answer is 0. So we are done. And next question, again the similar type of question, u equal to f of x square plus 2yz, y square plus 2zx. But this question we have to calculate separately. Now take a equal to x square plus 2yz, b equal to y square plus 2zx. Then u is now function of ab. So we need ux. Ux will be by chain rule del u del a del x plus del u del b del x. Only a and b are there. So if you write, this will be del u del a and del a del x is 2x, only 2x, plus del u del b and del b del x is 2z. Now we need in the expression y square minus zx del u del x. So if we multiply y square minus zx with the ux or del u del x, we will be getting 2 into xy square minus x square z del u del a plus 2 into y square z minus z square x del u del b. And then calculate del u del y. So for del u del y or uy, the chain rule is del u del a del y. And del a del y is 2z, and del u del b into del b del y is 2y. So in the expression we need x square minus yz del u del y. Hence calculate x square minus yz into uy equal to 2 into x square z minus yz square del u del a plus 2 into x square y minus y square z del u del b. And the last one is we have to calculate uz or del u del z, which is del u del a and del a del z. Del a del z will be 2y and del u del b and del b del y is 2x. Now in the expression there are z square minus xy uz. So calculate this one. This will be 2 into z square y minus xy square del u del a plus 2 into xz square minus x square y del u del b. Now in the expression we need sum up of all these three quantity. So add these three quantity, then the LHS, there will be ux. Check this, y square minus zx into ux. So now adding all these three quantities, we will be getting 2 we can take outside, and del u del a and del u del b we can take separately outside. So del u del a and then take 2 also. So it will be xy square minus x square z plus x square z minus yz square plus z square y minus xy square, plus take 2 into del u del b and then y square z minus z square x plus x square y minus y square z plus xz square minus x square y. Now you can see all the things will be cancelled out. Xy square minus xy square, yz square plus z square y, and everything is cancelled out. So answer is 0. Hence proved. So if you like the solution, please press the like button and subscribe the channel for more such solutions. And if you have any doubt, then comment also.